it's probably bad, and how we do that. Pretty exciting stuff. First thing we do when we have a file and we think it's bad, we just do what I call the boring stuff, the stuff that we have to do. And it's how big is it, what's its name, what's its MD5 sum or mathematical checksum, and a few other things. I also recommend you use PEView, which is free, and say, when was this thing compiled? That's key because, well, until this presentation, we haven't seen attackers lie about the compile date. So, and let's hope they continue to not listen to me and keep putting the real data there, because it's very helpful to us. We now know this backdoor has been used since only July 25th of 2006. It's their current stuff. What's odd is we're normally about a year behind the compile date when we find these things in the wild. We do virus scan them. I'm not sure exactly why, other than to tell the client, hey, your AV is not going to help you here. That's all we get out of that. If you find something on your machines at work or at home and you want to know what they do, take that executable, put it through jotty.org, or you can go through virustotal.com. VirusTotal actually runs more virus scans. The catch is every time I found something bad and ran it through these, it didn't detect it. So, like for example, you have a screenshot here of the file as.exe going through 14 antiviruses. None of them detected it as bad. There's a port redirector that was packed with the most common packer called UPX. So, kind of interesting. You've heard me mention armoring. I just want to quickly say what I mean by that. It could mean that there's a program that's been encrypted or compressed, and that just means that the beginning header code of this, of the backdoor or the malware unencrypts itself in pieces. It's almost like steganography for executables. And it's very hard right now, if it's not a publicly available packer, to identify how it's been packed. There's so many different things folks can do with their executables. And these things all exist. You can have an executable as a bad guy where it will only run at certain times, and if somebody gets your code and tries to run it, it just doesn't work. It can reset your BIOS time and date, so it works on its victim system. But when you take it to your analysis platform, it checks your BIOS time and date and says, won't run, won't work. And that's common. Restrictive dates where it only runs on certain timetables. Password protected is the most common. The code will not execute unless you give a password on the command line. And if you can't do the right password, then you can't do dynamic analysis. That's an easy one to get by, though. Anti-tracing is annoying. Chris, have we ever run into anti-tracing? No. Good. Could we build it quickly? Yes. And that'd be annoying. Anti-tracing means we're running the bad malware. We're sitting in a debugger, whether it's Ollie debug or soft ice, and as we single step, the program goes, they're single stepping, crash the debugger. Or they're single stepping through our program to see each individual step of what our program does. Let's do a different executable, different decision tree. So, anti-unpacking tools, that's fine. Here's all the packers out there if you have an interest. I'm trying to pique some of your interest. My guess right now is one of the best ways you can find compromised hosts on your organization is if you had the magic widget that went to every single file on your network and said, is it packed or not? And if it was, it's probably malicious code. Right now what we use is PEID. It's currently version 0.94, and it actually will detect 450 different types of packers being used right now. It doesn't tell you how to unpack them. That's a whole nother battle for you. But PEID is free. It's available at a site in Italy. I highly recommend it because it does recursive searching for packed executables. It's very powerful. We like it, and we use it. Unpackers are all over the place. We use ID8 Pro's Universal Unpacker plugin. We use the Ollie Dump plugin. And after that, we kind of use whatever widget we can find that works. The most common things that being used to pack programs right now are fast, small, good. For some reason, it seems to be very common from the folks in Romania and Eastern Europe. And you need FSG or un-FSG to crack that. And I'll skip that. UPX is still common. I'm amazed it's still in use. But you need to unpack things in order to have strings work for you. And notice that all the steps I'm teaching you to determine is this bad code or good code or who knows what it is you're not executing the code itself yet. The next thing is strings. It's a public available command. I'd recommend using the one from sysinternals, now wininternals, I believe, that Mark Brzezinowicz wrote because it can do Unicode searching as well. And you need that. The Sigwin version of strings does not do the Unicode searching. And I highly recommend that you do this because when you look at the strings in a code, there might be unique enough strings that you can go out to the internet and without attribution to you, find source code or a user manual. I can tell you this, most folks that live in a lab doing nothing but malware analysis, the minute they get malware, they just get in that rut of what does it do? And they immediately open up IDA Pro and they start ripping through it. Unbeknownst to them, they have 3 days to either A, go grab the manual off a site somewhere at a university in China, or B, maybe find out that, geez, all our data that we've lost just went to a compromised 3rd grade classroom in Mississippi, and wouldn't it be nice to go grab that and contain it? And that's exactly what is important when you do strings, is you'll find those fully qualified domain names. We happen to do it pretty quickly. We try to maintain the discipline to always do web research that's non-attributable to us. That means we don't go right back to the hacker's IP address or anywhere near them if we can help it, and I don't know of an exception to that. But we went through a program that we found on a machine, and you can see every bullet here is unique strings in a program that we unpacked, and it was packed with a custom packer. So we had to, basically execute it and dump RAM to get it unpacked. So you can see that there's a lot of unique strings, like they spelled delete, D-E-L-T-E, Squelta 1.0, Bingle's an actual guy. I still don't know who the heck he is. But we found the source for this stuff just by doing a Google on these unique strings, and we found the manual. Now, granted, it was in Chinese, and we had to use the Google translator to translate it, but we learned a lot about this tool, and it helped us for tool analysis just by going through this stuff. So you can see it right there. Another thing, if you're ever looking for attribution on who's hacking you, we found a file called let.exe. I did a Google for let.exe, and, well, every single site that has it had a certain character set. Disassembling tools, you have to unpack tools to disassemble them, period. So if you're a bad guy, you pack them. If you're a good guy, you got to figure out how to unpack these things. It's a common war. It's kind of like rootkit detection. If you can detect that rootkit, they up it so you can't. If we can unpack it, they update it so you can't. Same type of thing. Most commonly used tools here are PEView in my mind and IDA Pro. And IDA Pro is the staple standard because it handles ELF executables from Linux machines as well as the PE portable executable files from Windows. When you go through this, you have 2 options at this point. You're at a fork in the road. Do I want to do malware analysis for the next 8 weeks, get good at it, and become the malware guy? Or do I just want to have enough interest that every once in a while I kind of take a peek at it? IDA Pro, I believe, is over $2,000. There is trial versions that are very effective as well to at least help you say that certain things are bad. And there are free tools for dynamic analysis, so you may not have to do disassembly. But when you do disassembly in IDA Pro in general, you can find those following 4 bullets very quickly. Does something use a network? Does something open up raw sockets? Does it encrypt itself? Does it use XOR encoding? Does it write to files, read files? Does it copy itself? All these things you get used to recognizing as constructs, so you can rip through it pretty quickly. What I'm going to end up doing someday is what I'm going to call the, someday we have to do it. I don't want to call it the Idiot's Guide to Malware Analysis or, Malware Analysis for Dummies. That's just not right. So we're going to call it Malware Analysis for Really Smart People that Work Hard. And one of the things that would have to be in that book is, here's Windows APIs that when called could mean the following, and it's literally a pick list because it is that easy. I got a screen capture here using PEView. We're looking at a potential piece of malware, and we just need to know what DLLs are imported by this. Well, kernel 32, no surprise, you're going to see it. Advapi 32, most of the time it's called as well. But you see down at the bottom, the WinSock 32 libraries. This thing's going to talk on the network. It's going to do something on the network. And then you can go and look at what specific functions are used inside of that DLL. Anytime you see something call Advapi 32 and say that I'm going to open and set registry values, that means it's opening up the registry, and almost everything does this anyway, but at least now you know this program writes to the registry, reads from the registry, and does stuff with the registry, and you know where to look once you start looking at the dead list or disassembled code. And it's also fantastic to know when the function's being used by WinSock, and this one's very interesting. We even circled the sleep function. If you look at this, WSA cleanup, WSA socket, WSA startup are called every single time a Windows program uses this API, and it's going to use the network. Fine. But you see the host to network short, HTON's call. What that means is the Intel little Indians getting flipped to network byte order. This thing's automatically talking on a network if you see the HTON's function used. INetAddr, it's converting something to the IP address format we're all familiar with. Sleep, beaconing, period. That's this thing going out every hour or every 2 hours or every 30 seconds. This is a very common, just by seeing this, I magically know, I don't know of a normal process, period, that says, hey, I want to listen on the network and then go to sleep every once in a while, and screw the people that want to tell that to me because I'm sleeping for now. This is a process that's beaconing outward to a bad guy somewhere. So it's kind of neat. And then final bullet, and I only have 1 minute, for incident response. Because attackers are using more sophisticated tools and moving fast, we have to move faster. And I'll leave you with the last thought, and it's probably the hardest thing to do when you're managing an incident, is once incident is detected, you want to prevent the darn thing, but the only way to prevent it is you need to determine the host-based countermeasures. What ports is the guy speaking on? What's the network-based signature? And you need host-based detection and prevention mechanisms. And the problem is you don't know what those are until you start investigating. The longer it takes you to investigate, the more information you have about the bad guy, and you have better remediation. Problem is, flip that over, the longer it takes you to investigate, the more stuff you're losing, the more widespread the intrusion is, and the harder it's going to be to remediate. So you really have to work fast, have the expertise, compress the time frame in which you solve. Here's how we find this guy via host-based detection mechanisms, meaning what log files does he write to, what user accounts is he using, what registry entries are indicative of his backdoor, what are the MD5 sums of his backdoor, the file names of his backdoor, the event log entries, significant, that represent his activities. Whatever it happens to be, you need those. And then you also need to know, here are the strings we look for on the network, because almost every backdoor we've ever found does have a unique indication that doesn't have a lot of false positives. With that, I think we're done, and we're about to hand out a few, I'm going to just advertise the party, and I have a few books to give out. This first one, all you have to do is be the first one to answer the following question correctly. What team won the Super Bowl last year? I think the sound travels too slow from the back, so I'll ask one in the middle. Steelers, a.k.a. the best team. All right, and then this one's an easy one. What number did Rocky Blyer have? 20 is right. Someone down there. Got it. And Mike, do you want to do the giveaway for the PlayStation? What's that? Thank everybody for being here. If you have any questions, any comments, I'm going to be around. Thank you very much.